Hello everybody, myself Dr.Purna, Professor and HOD Physics, Government VYT PG Autonomous College, Durg. Now, today I am going to represent one practical which is in the syllabus of M.Sc second semester now of Durg University. Now, the object is to study the amplitude modulation and demodulation. Now the apparatus required transistor, either PNP and NPN. We have used PNP transistor in this case. Resistors, capacitors, audio frequency oscillator, CRO, that is cathode ray oscilloscope, diode. We have used OA79, multimeter, regulator, power supply and breadboard. Now let us discuss the theory. Modulation is defined as a process by which some characteristics of high frequency wave such as amplitude, frequency or phase is altered in accordance with instantaneous value of some other voltage. Modulating voltage is an information signal, while the voltage undergoing alternation is a high frequency and is called carrier signal. Now we will discuss here amplitude or modulation. So let the carrier voltage is explained as EC equal to capital EC cos of omega c t plus theta. Now where capital EC is amplitude of the carrier voltage wave, omega c is the angular frequency of the carrier wave, theta is phase angle. The magnitude of carrier wave varies in accordance with the amplitude and frequency of the modulating voltage, which is taken as signal. That is, signal voltage EM, small em equal to capital EM cos omega m into t. Carrier voltage EC equal to small capital EC cos of omega c into t. Let it be equation number 2. The first equation is for EM, modulated wave, that is equation number 1. The resulting modulated wave has been E equal to capital EC plus K alpha EM cos omega m into t cos omega c t plus theta, which is taken as equation number 3. The amplitude factor EC equal to EC plus K alpha EM cos omega t represents the sinusoidal variation of amplitude of the wave. K alpha is a proportionality factor which determines the maximum variation in the amplitude for a given signal voltage EM. Now, phase theta is taken to be 0 because it plays no part in this process. Hence, equation 3 can be written as E small e equal to capital EC 1 plus K alpha EM upon EC cos omega m into t cos omega c into t, or small e equal to EC plus m alpha cos omega m t cos omega c t, where m alpha is equal to K alpha EM upon EC, where m alpha is a modulating factor index, or small e equal to EC cos of omega t plus EC upon M alpha upon 2 cos of omega C plus omega M into T plus EC into M alpha upon 2 cos of omega C minus omega M into omega M into T, which is equation number 4. Now, on the basis of the above three terms given in equation 4, which has different frequency terms, these frequencies are arranged in bands as shown in figure 1. Now, this is figure number 1. Now, along y-axis we have taken amplitude, along x-axis we have taken all the three waves. The first one is the modulated frequency. Along this axis we have taken frequency, that is omega m denotes the modulating frequency. Second, lower side band, that is omega c minus omega m. This represents omega c, the carrier frequency, and the last one, the upper side band frequency, which is given by omega c plus omega m. Now here EC cos omega t is the original signal voltage. M alpha EC upon 2 cos of omega c plus omega m into t is the upper side band, and the lower one is lower side band is M alpha EC upon 2 cos of omega c minus omega m, which is denoted by lower side band. This is this one. Now let us come to the theory. On the basis of these three terms, we have shown that there are three frequencies which are change frequencies, and we have shown it in the figure 1. The magnitude of amplitude of both the upper and lower side bands is M alpha EC upon 2. If M alpha be unity, then each side band term is half the carrier voltage, because it is given by M alpha EC upon 2, the amplitude of both the waves. Carrier voltage in amplitude, the value of M alpha is given by M alpha equal to E maximum minus E minimum divided by E maximum plus E minimum. Now, M alpha ranges from 0 to 1. The circuit diagram for the modulation is shown in figure 2. This is the circuit diagram which is shown in figure 2. Now, we have used a PNP transistor, and the collector circuit gives the output, which is connected with modulated output signal, which is connected with this circuit. There is one filter circuit, and the output is taken out. In the output, it is detected with the help of a CRO. This CRO can be connected in this here, and it can be, the waveform can be seen on the screen of the CRO. Now, in the input circuit, the radio frequency carrier wave is supplied from here. Now, this is connected with the base, and between the base and this circuit and emitter. Now, this denotes the radio frequency amplifier, and here we have connected the modulating signal, and this minus VCC denotes the voltage. Now, modulating signal has been applied to the collector in series with DC collector supply voltage transformer. Now this matches the output stage of the modulating amplifier with the collector load of class C amplifier. Capacitor C often lower reactance to radio frequencies but high reactance to the modulating signal frequencies. Thus, it grounds the carriers and serves to keep the radio frequencies out of the modulation circuit and out of power supply. To obtain 100% modulating maximum value of modulating voltage E must have equal power supply voltage VCC. Under these conditions, the radio frequency output of the modulating amplifier is 0 at the negative peak of the modulating signal. Then we have EMM equal to VCC. Now IMM equal to IC. Now P0 is given by EMM into IMM by 2. This is equal to VCC into IC upon 2. The effective load in the modulation is given by RL equal to EMM upon IMM equal to VCC upon IC. Now figure 3 shows the modulating wave, carrier wave and amplitude modulated wave. Now this is figure 3. First one shows the modulating wave. Omega m is the frequency. Now EM is the voltage, modulating voltage, and we have drawn the graph between EM and time t. It varies like this, that is low frequency. The second one shows the carrier wave omega c, which is of high frequency, and now EC denotes this frequency, and this is EC versus T graph. The third one shows the amplitude modulated wave. So this is the whole diagram for amplitude modulated wave. Now EC denotes the carrier wave, E maximum is the maximum value of the voltage, that is amplitude, maximum amplitude, and E minimum is the minimum value of the voltage. Now this is amplitude. The figure C shows the amplitude modulated. To obtain 100% modulating voltage, we have shown it. Now let us carry with this. Now figure 3. In figure 3 we have shown that A denotes the modulating wave, B denotes the carrier wave, and third figure shows the amplitude modulated wave. Now this is all about amplitude modulation. Now let us discuss the amplitude demodulation. Now demodulation is the process in which the original modulating voltage is recovered from the modulated wave. Demodulation is the reverse process of modulation. Now in amplitude modulation envelope, the carrier envelope has symmetrical variation of its positive and negative half cycles that corresponds to the modulating voltage. As this envelope is symmetrical, the mean value of the mean value detected or rectified radio frequency current is 0. Therefore, it increases. As this envelope is symmetrical, the mean value detected or rectified radio frequency current is 0. Therefore, increases devices are used which make the modulated wave unsymmetrical, either by wiping out the negative half radio frequency cycles or by making positive and negative half cycles unequal. Consequently, DC or mean value detection radio frequency current then rises and falls at modulating signal rate and may be separated by employing suitable filters. The circuit diagram is shown in figure 4. This is the circuit diagram. Here, this is linear diode detector circuit for demodulation. This is the diode, this is the tank circuit, and this is the filter circuit, and output is in the output CRO is connected where the waveform of the demodulated wave can be traced out. Now the circuit diagram is shown in figure 4. Linear diode detector utilizes the rectification characteristic of diode in half wave rectifier. The load and the ripple will be very small and can be removed by the filter circuit in the output circuit. This is the filter circuit. This can be removed. This is used to remove the small ripple factors removed by the filter circuit in the output circuit. Now the result, the amplitude modulation and demodulation waveform can be traced on tracing paper when CRO is connected in the output circuit. As I told you earlier, the waveform for modulated wave is shown in figure 3C and that of the demodulated wave is shown in figure 5. Now this is the figure 5 which shows the demodulated signal, the output signal we receive, the demodulated signal. Here along y-axis we have taken the amplitude and along x-axis it varies with time. Time must be here. Now this is the demodulated signal we get. Now this is the result. Now what precautions we have to take? The connection should be made as shown in figure 2 and figure 4 for modulation and demodulation respectively, and connections should be tight. The power supply should be switched off after completion of the experiment, and the open end of the wire should not be touched when the power supply is on. The waveform should be traced on tracing paper with precaution which is formed on the screen of CRO. Now thank you very much for listening to my video. Now please react whether you liked it or not. Thank you.